What is the tallest structure ever built?
Structures and towers are listed separately from skyscrapers. The Warsaw Radio Tower on the outskirts of Warsaw, Poland, was the tallest structure ever built. Although it needed to be supported by long cables to keep it up. The tower reached 646 meters, 2,119 feet, into the sky. Unfortunately, in August 1991, the tower came crashing down during repair work. The tallest structure ever built that is still in existence is the KTHI-TV Tower in North Dakota, which stands with the help of cable 629 meters, 2,063 feet, tall. The tallest self-supporting tower in the world is the Canadian CN Tower, whose tip is 553 meters, 1,815 feet, above the city of Toronto.
What type of wave is a water wave?
Ocean or water waves look like transverse waves, yet are actually a combination of both transverse and longitudinal waves. The water molecules in a water wave vibrate up and down in tiny circular paths. The circular path of the water wave creates an undulating appearance in the wave.
What is quantum teleportation and how does it use entanglement?
First, what it is not. It is not beam me up, Scotty, where a person disappears at one place and appears at another. It involves only information transfer by either photons or atoms. Teleportation involves an atom whose state is to be communicated from a sender, Alice, to a receiver, Bob. It also involves a source of two entangled photons. Alice first sets or measures the state of the atom. This is the information she will send to Bob. At the same time she measures the polarization of one of the two photons. This polarization information is the encryption key that will allow Bob to decode the information. Because the two photons are entangled, the polarization of the transmitted photon is fixed. Bob now has the key that allows him to decode the information Alice sent. In practice, of course, the encryption key isn't the polarization of a single photon, but many. The longest distance information has been teleported is 16 kilometers through the air in Beijing.
How does an FM band station transmit stereo sound?
Stereo sound means that two separate sounds, the left L and right R, are produced from a pair of speakers. Because stereo broadcasts must also be usable by receivers that cannot reproduce stereo, the signal that all receivers can detect consists of the sum of the left and right channels, R and L. The difference of the two channels, R, L, is broadcast 38 kHz above the R and L signals. Mono receivers can't detect these very high frequencies. The stereo receiver, though, can, and from the R and R, L signals creates separate R and L signals to be amplified and sent to the corresponding speaker. FM stations have enough bandwidth to accommodate a third signal. This signal can be sold to users to provide background music for stores or elevators. Education stations can deliver lessons to schools, or broadcasts in a second language.
What is a barometer?
Device to measure gas pressure.
What is astrophysics?
Study of how astronomical bodies, such as planets, stars, and galaxies, interact with one another.
Do electrons and neutrinos interact with quarks and gluons?
Electrons and neutrinos are called leptons, meaning a lightweight particle. They don't participate in the strong interaction, so they don't interact directly with quarks and gluons. They are, however, involved in the weak interaction through two additional force carrier particles. The W and Z bosons that can interact with quarks. Beta decay involves neutrons, protons, electrons, and neutrinos.
What is a decibel, dB?
Unit of relative intensity of sound.
What are the secondary colors in subtractive color mixing?
The secondary colors for dyes and pigments are the same as the primary colors in additive color mixing. Red, green, and blue dyes or pigments reflect their own color while absorbing the other two colors. For example, red would reflect red but absorb the green and blue light.
What allows nocturnal animals to see better in the dark than humans can?
There are three main reasons why some animals can see better than humans can at night. The first reason is that their eyes, relative to body size, are larger and can gather more light than human eyes can. More light results in a brighter image. The next reason has to do with the rods and cones in the nocturnal animal's eyes. Cones are used for detail and work best in bright light. A nocturnal animal has little need for the color vision provided by the cones and therefore has more room for the rods that detect general information such as motion and shapes. The third reason why nocturnal eyes excel in the absence of light is due to the tapetum lucidum, a membrane on the back of the retina that reflects light back to the retina to double the retina's exposure to light. The reflective tapetum can be seen in the light reflected back out of animals' eyes at night when you shine a flashlight on them.
Why don't we feel this atmospheric pressure?
First, it is exerted uniformly on all parts of our bodies. Second, it is balanced by pressure from the insides of our bodies. We can feel the pressure if you try to breathe in but close your mouth and pinch your nose closed. You can tell that the external pressure on your lungs exceeds the internal pressure.
What plays the role of momentum in rotational motion?
The angular momentum of a rotating object is proportional to the product of its moment of inertia and its angular velocity. If there are no external torques on the object, then its angular momentum does not change. An object with linear momentum that has no external forces on it cannot change its mass, so its velocity is constant. But a rotating object can change its moment of inertia, so even without external torques, its rotational speed can be changed.
What happens if you get close to a charged Van de Graaff?
The sphere on the Van de Graaff is a conductor surrounded by an insulator, the air. While there are strong forces on the negative charges on the sphere, they're not strong enough to break down the insulating properties of the air. If, however, you bring another object with less negative charge close to the generator, the forces on the air molecules can become strong enough to rip them apart, separating their negative electrons from the positive nuclei. A spark will jump. If that object is your finger, you'll feel a shock when the charges carried through the spark move through your body. While the shock can be painful, one produced by the kind of Van de Graaff in physics classrooms is not harmful.
Does sound travel faster on a hot or cold day?
Air molecules move faster in hot and humid environments due to their increased thermal energy. Since sound relies on molecules bumping into one another to create compressions and rarefactions, increased speed of molecules makes the sound waves move faster. The speed of sound increases by 0.6 meters per second for every degree Celsius increase in temperature. Water vapor in the air also increases the speed of sound because water molecules are lighter than oxygen and nitrogen molecules. Therefore, on hot and humid days, sound travels faster than on cool, dry days. The following formula gives the speed of sound in air. Speed of sound equals 331 m/s, 1 plus 0.6 T, where temperature, T, is measured in Celsius.
What is a Faraday cage?
A Faraday cage, named after British physicist Michael Faraday, is a cage. Metal grating, or metallic box that can shield electrical charge. Charges gather on the outer shell of the cage because they are repelled by one another and can be further from each other if they are on the outside of the cage. This results in no charge within the Faraday cage. The metal sphere of a Van de Graaff generator is a Faraday cage. Cars and airplanes can be Faraday cages as well, and may provide some protection from lightning during an electrical storm.
What is energy?
An object with energy can change itself or its environment. That's a pretty abstract definition. Let's explore some of the many ways an object can have energy and what changes it can cause. A speeding car has energy. Think what damage it can do if it hits a wall or another car. The energy of motion is called kinetic energy. A rotating wheel also has energy. If you try to stop a spinning bicycle wheel with your hand, it may hurt you. This kind of energy is called rotational kinetic energy. A compressed spring or a stretched rubber band can cause a stone to move. The energy in the squeezed spring or stretched band is called elastic energy. There are a variety of other forms of energy that are stored in a material. The random motion of the atoms that make up the material means that the atoms have kinetic energy. A measure of the amount of the kinetic energy in the random motion of the atoms is called temperature. The more energy, the higher the temperature. Kinetic energy in the random motion of atoms in a material is called thermal energy. If you charge or discharge a battery, like the one in your cell phone, you change the chemical composition of the battery materials. When you charge it, you increase its chemical energy. You can also increase the chemical energy of your body by eating. Even mass has stored energy. Splitting the nucleus of a uranium atom results in elements that have smaller mass but a large amount of kinetic energy.
What is the principle of equivalence?
A central tenet of Einstein's general theory of relativity. The laws of physics in an accelerating reference frame or a gravitating frame are indistinguishable. You can't tell the difference between falling or being acted on by gravity. Requires that inertial mass equals gravitational mass.
What is electricity, vitreous?
Produced when glass or precious stones are rubbed.
What is friction force?
A force due to an interaction between an object and the surface on which it rests. Always in the direction opposite the motion. Depends on the force pushing the surfaces together. In most cases is larger if the surface is rougher. Generally doesn't increase if the speed of motion increases. Friction equals Nn.
What is a real image?
A concave mirror or a convex lens can redirect light from an object so that it does converge to a single point. That point is a real image. It is in front of a concave mirror and on the other side of a convex lens from the object. If you place a screen, piece of paper, or wall at the location of the image, you'll see it on that surface.
What is a dispersion?
Light of different colors are refracted into different directions caused by wavelength dependence of refractive index.
Does the United States use SI?
Although the American scientific community uses the SI system of measurement, the general American public still uses the traditional English system of measurement. In an effort to change over to the metric system, the United States government instituted the Metric Conversion Act in 1975. Although the act committed the United States to increasing the use of the metric system, it was on a voluntary basis only. The Omnibus Trade and Competitiveness Act of 1988 required all federal agencies to adopt the metric system in their business dealings by 1992. Therefore, all companies that held government contracts had to convert to metric. Although approximately 60% of American corporations manufacture metric products, the English system still is the predominant system of measurement in the United States.
What is the electromagnetic spectrum?
The electromagnetic spectrum is the wide range of electromagnetic M waves from low to high frequency. The spectrum ranges from low-frequency radio waves all the way to gamma rays, which have a very high frequency. In the middle of the spectrum is a small region containing the frequencies of light.
What happened to Democritus and Aristotle's ideas?
For almost 2,000 years Aristotle's philosophy was taught in schools and accepted by educated people. In the 16th century doubts about Aristotle's science increased. A number of philosophers, including those whom today we would call scientists, actively opposed Aristotle's dominance of the curriculum in schools. Englishman Francis Bacon, 1561–1626, developed what we today would call the scientific method in opposition to Aristotle's philosophy. In 1612 Galileo, 1564–1642, published Discourse on Floating Bodies in which he envisioned atoms as infinitely small particles, views that he later expanded in the Essayer. 1623, and, more completely, in Discourses on Two New Sciences, 1638. Nevertheless, the debate over whether atoms, much too small to see, really existed or were just a successful model of matter continued for another 2 centuries.
Shear force?
Force exerted that parallel to a plane.
Does the dimension of an antenna play a significant role in the reception of an electromagnetic wave?
The length of an antenna determines the frequency that it best receives. The most efficient antennas have a length equal to half the wavelength of the wave it is receiving. This allows the induced electrical current in the receiving antenna to resonate at that particular frequency. If the antenna is a simple rod, it is most sensitive when its length is 1/4 the wavelength. A loop or coil antenna are used for the low frequency, long wavelength signals in the AM band. A half wavelength straight wire antenna would be over 100 meters long. Shorter wires or rods can be used and are more efficient if coils of wire are used to load the antenna. Home FM radio and television antennas are designed to receive a broad range of frequencies, but with less sensitivity. Antennas for the ultra-high frequencies used in digital high-definition televisions are very short and can be easily mounted outside on rooftops or on top of television sets.
What is the standard unit for mass?
The kilogram is the standard unit for mass in SI and the metric system. The kilogram was originally defined as the mass of 1 cubic decimeter of pure water at 4 degrees Celsius. A platinum cylinder of the same mass as the cubic decimeter of water was the standard until 1889. A platinum iridium cylinder with the same mass is permanently kept near Paris. Copies exist in many countries. In the United States, the National Institute of Standards and Technology NIST, houses the mass standard, as well as the atomic clocks that define the second. The kilogram is the only standard unit that is not based on atoms or molecules. Several methods are under development to define the kilogram in terms of the mass of the carbon atom. Currently, one method has a precision of 35 parts per billion. That is equivalent to measuring the mass of your body. And the change in mass if one hair falls off your head.
Are pulleys really simple machines?
A fixed, or unmovable, single pulley can be considered a wheel and axle where both have the same radius. The mechanical advantage is one, but the pulley changes the direction of the force. If the pulley is allowed to move and the output force is exerted by the axle of the pulley, then the input force is shared by the two ends of the rope. If you fasten one end and pull up on the other, then you achieve a mechanical advantage of 2. A combination of fixed and movable pulleys is called a block and tackle. Archimedes is said to have pulled a fully loaded ship using a block and tackle. Energy loss in a block and tackle comes from friction between the axle and its holder, as well as the stretching of the rope and rolling friction between the rope and pulley.
What is an open circuit?
Circuit that is open so no charges flow.
What are the two ways to charge an object?
When a rubber rod is rubbed with fur, the fur transfers electrons to the rubber rod. The rod and fur, originally neutral, are now charged. If an object touches the rod, some of the excess electrons on the rod can move to the object, charging it. The rod, which is now negatively charged because it has excess electrons, can attract positive charges. This method is called charging by contact. But, as you observed with the cellophane tapes, your hand and other neutral objects attract both positively and negatively charged objects.
What is entanglement?
Consider what happens when a positron and electron annihilate. Two gammas, high-energy photons, are produced that go off in opposite directions, 180 degrees apart. They can be detected many meters from their source and have opposite spins. But which gamma has which spin is a random choice. That is, for each gamma there is a 50/50th chance that it will be in a particular direction. Suppose you find that the spin of one gamma is pointing up. But, the moment you detect the spin of that gamma, the spin of the other gamma must be pointing down. The result of one measurement determines the results of the other. The two detectors would measure the spins of their gammas at the same time. So there is no way that one gamma could communicate with the other gamma. Physicists say that the spins of the two photons are entangled and that the spin state of each photon is the superposition of the two possible spin directions. When the spin is measured, the wave function collapses and gives a definitive result. Albert Einstein, 1879 to 1955, called results like this spooky action at a distance. Others have called it quantum weirdness. Similar results can be obtained with atoms or ions, in which case the photons are light quanta and may be transported through space, or the air, or by optical fibers. For example, if an atom is excited by the absorption of a photon, it can emit two photons that are entangled the same way the gammas are in the example above.
Why do you sometimes get a shock when touching a doorknob?
This annoyance happens usually on dry days after walking on carpeted floors. The friction between the carpet and your shoes or socks causes charges to be moved between your body and the carpet. Usually your body becomes negatively charged. When your hand approaches a doorknob, the negative charges in your hand are attracted to the positive charges in the doorknob, created by polarization, causing an electrical spark when the two charges meet. Circuit boards are sensitive to electrostatic buildup and can be damaged if such a charge accumulates on sections of the circuit.
How does the spectrum of a sound relate to its waveform?
Jean-Baptiste Fourier, 1768 to 1830, a French mathematician and physicist, made discoveries in a number of fields, including the greenhouse effect. He developed mathematical tools known as Fourier series and transforms that are used in a wide variety of applications. The Fourier theorem states that any repetitive waveform can be constructed from a series of waves of specific frequencies, of fundamental and higher harmonics. The reverse is also true if you add together waves of frequencies f, 2f, 3f, etc., specifying their amplitudes, you can construct a complex waveform. Using Fourier analysis, then you can record the waveform of a musical instrument and determine the amplitudes of the harmonics of which it is made, that is, its spectrum. Today Fourier analysis is very easy to do. Most computers either have built-in microphones or can use an external microphone. Free software can be downloaded from the web that will display the spectrum.
How do fluids model electric charges? How could these results be explained?
Charles François Dufay, 1698 to 1739, concluded that there were two types of electricity. He named them vitreous, meaning glass, precious stones, and resinous, amber, sealing wax. Silk. Friction separates the two types. When they are combined they neutralize each other. Jean-Antoine Nollet modeled these types as two fluids, each composed of particles that repelled each other. Charging amber gave it an excess of resinous fluid. Charging glass with silk gave it an excess of vitreous fluid. When the two were touched together the fluids combined with each other leaving the objects unchanged arged. Benjamin Franklin believed there was only one fluid. When glass was rubbed the fluid filled the glass. When amber was rubbed the fluid left the amber. He called an object with an excess of fluid positive and one with too little fluid negative. When they were touched the fluid flowed from the glass to the amber, leaving each with its proper amount of fluid. The flow was likened to water in a river. The electrical tension, difference in potential, and electrical current were analogous to the difference of water levels between 2 points and of the amount of water transferred.
What is the index of refraction for light traveling through different media?
The following are some sample indices of refraction. The index of refraction, represented by n, is the ratio of the speed of light in a vacuum divided by the speed of light in the material. The larger the index of refraction, the greater the bending that takes place.
What is the law of reflection?
Angle of incident light is equal to angle of reflected light.
What is pressure, P?
Force divided by area over which force is exerted.
What is radio astronomy?
Uses VHF, UHF, and microwave portions of the electromagnetic spectrum to study planets, stars, and galaxies.
What happens when light hits a sheet of paper?
Replace the mirror with a sheet of paper. Darken the room. Aim the flashlight at the paper and use a second sheet to catch the reflection. You'll see that the second sheet is illuminated in many different locations. The light is reflected from the paper, but into many directions. This kind of reflection is called diffuse reflection. Polished, smooth surfaces that do not absorb light are the best reflectors. Examples of reflective materials are shiny metals, whereas non-reflective materials are dull metals, wood, and stone.
What materials are used for static structures?
The first materials used were made of stone. Especially stones like flint that could be chipped to make sharp edges and points. Ancient peoples discovered metals, either in pure form, or in ore, that is mixed with non-metals. Copper, tin, gold, and iron were known before 2000 BCE. Copper, tin, and gold are very soft and not very useful as tools or weapons. A method of hardening metals is to mix two or more different metals forming what is called an alloy. Bronze is made by adding tin to copper and was known by about 4000 BCE. In what is now Iran and Iraq. The tin came from southern England. Bronze is a hard metal that can be melted and cast in various shapes, including statues. Today bronze is used for bells and cymbals. Not much later methods were found to convert iron ore, which is iron mixed with either oxygen or sulfur, to pure iron using a charcoal fire. Iron replaced bronze as a material for tools and weapons because it was cheaper and didn't require long trade routes to obtain the tin. To keep iron from being brittle, the carbon must be removed. If the iron is heated to red heat and then hammered, the carbon is forced to the surface where it can be removed. The result is steel that contains less than about 1% carbon. Steel is a versatile alloy of iron and carbon because additional materials can be added to change its properties. Very hard steel, called tool steel, contains tungsten, molybdenum, and chromium, among other minor additions. Its hardness can be changed by heating it and then cooling it very quickly by quenching it in water or other liquids. Stainless steel used in knives, forks, and spoons has 18% chromium and 10% nickel. Other stainless steels use different amounts of these two metals as well as molybdenum and magnesium. Stainless steel does not rust, but isn't as hard as tool steel. Pewter is a tin alloy that was developed in England for plates and cups. It adds copper, bismuth, and antimony to tin. Originally lead was used, but because it is poisonous, it is no longer found in pewter. Brass is typically 80% to 90% copper with zinc added. Actually, brass was made before metallic zinc was isolated. The zinc or calamine was melted with copper. Brass is used as a decorative metal as well as in bullet casings. If aluminium and tin are added, it is resistant to corrosion by seawater. Gold is another very soft metal. It can be made harder by adding copper and silver in equal quantities. Gold alloys are measured in carats. 24-karat gold is pure gold, while 18-karat gold has 18 parts gold and 6 parts other metals. 10-karat gold has 10 parts gold and 14 parts other metals. Titanium is used in many alloys today because it is lightweight and corrosion resistant. Many alloys of both metals and nonmetals are used in electronics. Some LED lamps contain the metals gallium and aluminium and the nonmetal arsenic.
How can you reduce the coefficient of friction?
One method is to use surfaces that have less ability to form chemical bonds. Teflon is one such surface. Another is to have a thin film of oil between the surfaces. The oil will prevent bonding of the atoms in one surface with those of the other. Oil or other lubricants can reduce the coefficient of friction to about 0.1 to 0.2.
What happens to an element when it decays by emitting an alpha particle?
The nucleus that results from a radioactive decay is called the daughter. The number of nucleons in a radioactive decay does not change, and in an alpha decay the number of protons of the original must equal the number of protons in the daughter plus the number of protons in the alpha. The same is true for the number of neutrons. So, for example, when uranium-238, with 92 protons and 146 neutrons emits an alpha, the daughter has 90 protons and 144 neutrons. It is thorium-234. The alpha is emitted with a specific energy. Only very heavy nuclei decay by alpha decay.
Why is a stone easier to lift when it is in water?
Even though the stone sinks because it is denser than water, there is still a buoyant force on it given by Uchtone, waiter, so the stone's weight is reduced. Floating usually refers to a liquid such as water, but can anything float in a gas? Remember that there is a difference in pressure of any fluid between the bottom and top of an object in it given by L bottom equals top plus pGh. Even though the density of a gas, P, is much smaller than that of a liquid, there is still a pressure difference, and therefore a buoyancy. There is another difference between a liquid and a gas. A gas can be compressed, and so the density of the atmosphere decreases as you rise. When a hot air balloon is launched, the air within it is heated and it will rise. As it rises, the density of the air decreases, and so the buoyant force decreases. At some height, the weight of the balloon and basket equals the weight of the air displaced, and the balloon stops rising. The operator of the balloon can go higher by making the gas in the balloon hotter, and thus less dense.
What is a block and tackle?
Simple machine that is a combination of fixed and movable pulleys.
What is a thermograph?
Picture that shows the temperature of every location in the picture. Thermometer device to measure temperature.
How has radar been used in astronomy?
In radar astronomy, electromagnetic waves are aimed at planets. By analyzing the reflected signals, the position, velocity, and shape of objects in our solar system can be determined. In the early 1960s, radar was used to determine the exact distance between Earth and Venus and Earth and Jupiter. Later, radar was installed on the space probe Magellan to map the surface of Venus. Radar astronomy has been beneficial in determining distances in our own solar system. But the reflected signals would be much too weak from objects outside our solar system.
Who introduced the modern chemical symbols?
Swedish chemist Jöns Jacob Berzelius, 1779 to 1848, introduced the modern chemical notation using one or two letters to represent an element in 1813. Rather than today's notation for water, H2O, Berzelius wrote H2O. Berzelius did much more. He published the first accurate list of the weights of atoms.
What is plastic deformation?
Object's shape changed after deforming force is removed. See elastic deformation.
What is aerodynamics?
An aspect of fluid dynamics dealing with the movement of air.
What is a physics education research?
Study of how people learn physics and how best to teach them.
What is an electroscope?
An electroscope is a device used to measure the charge on an object. It consists of two metal leaves, either thin aluminum foil or gold leaf, attached to a metal rod. If you touch a charged object to the metal rod, the two leaves will be charged with like charges. And so they will repel each other. The larger the charge, the greater the angle will be between the leaves.
What is a Newton, N?
Unit of measure of force. In the English system, force is measured in pounds, lbs.
What is a continuous spectrum?
Light of all wavelengths within a range produced by a hot solid or a hot, dense gas.
What were the implications of Ørsted's discovery?
The fact that moving charge in a wire could create a magnetic field created a great deal of excitement and enthusiasm in the scientific community. A week after hearing about Ørsted's discovery, French physicist and mathematician André-Marie Ampère (1775–1836) gave a presentation at the French Academy of Sciences that extended Ørsted's experiments and contained detailed analyses. A day later he found that two parallel current-carrying wires would either attract or repel each other depending on the relative directions of the currents. Ampere's greatest contribution, however, was the mathematical theory he created for electricity and magnetism. British chemist and physicist Michael Faraday's 1791–1867 philosophy led him to search for connections between phenomena like electricity, magnetism, and light. In 1821 he invented what is now called a homopolar motor. One end of a wire was suspended from a support so that it could swing in any direction. The other end of the wire contacted a pool of mercury. When Faraday put current through the wire, the end in the mercury traced out a circle. The force that Faraday had observed wasn't formalized until 1891 and then by the Dutch physicist Hendrik Antoon Lorentz, 1853–1928. This force, called the Lorentz force law, is proportional to the current through the wire, the magnetic field, and the length of the wire. The force, which is perpendicular to both the current and the magnetic field, is strongest when the current and field are at right angles. This force is the basis of motors and many other applications. When Faraday published his results, he failed to give credit to two other important scientists, and he was given assignments to work in other fields. Nevertheless, he continued to do experiments on the effects of magnetic fields. For example, he found that when dense glass was put in a magnetic field, the direction of polarization of light going through the glass was rotated. He spent 10 years searching for ways to create a current from a magnetic field. Finally, in 1831 he tried changing the magnetic field and made the crucial discovery that an electric current is produced by a changing magnetic field. The current, a flow of charges, is produced by an electric field exerting forces on the charges. Faraday went on to invent the dynamo, an early electric generator. The American high school physics teacher Joseph Henry (1797–1878) made the discovery at almost the same time.
What happens if more than one force acts on an object?
You can explore this question with your toy car or ball. Try exerting two forces, like two finger taps in the same direction. You can see that the car or ball moves faster. The forces add.
What is a crest?
The highest point of a transverse wave.
What is luminous intensity?
I response to intensity of light electromagnetic waves.
What is a standing wave?
The example used above showed what happened when two single waves going in opposite directions met. A continuous wave is a set of single waves, one after another. You can produce such a wave by shaking one end of a rope up and down at a constant frequency. Now, if the other end of the rope is tied to something that doesn't move, the wave will be reflected back toward you. If you shake the rope at the correct frequencies, the two waves will overlap each other and will seem to stand still. Producing a standing wave. Two distinct regions on a standing wave can be seen. At certain points the rope won't be moving. That point is called a node. The point where the motion of the rope is largest is called the antinode. The nodes are locations of destructive interference where the two waves moving in opposite directions have opposite amplitudes. The crest of one wave and the trough of the other are at the same location. The antinodes are at locations of constructive interference where the two waves have both positive or negative amplitudes, that is, both are either crests or troughs. The frequencies that produce standing waves depend on the length of the rope and the velocity of the wave on the rope. The lowest frequency will have nodes at the two ends and an antinode in the center. The next higher frequency will have a node in the center and ends and two antinodes. At each higher frequency the number of nodes and antinodes increases by 1.
What happens to an airplane when it is struck by lightning?
Airline pilots tend to avoid thunderstorms, but when a plane is struck by lightning, the passengers inside the plane are kept perfectly safe. For they are inside a Faraday cage, which shields them from the massive electrical charge. The lightning can, however, disturb and even destroy some of the sensitive electronics used to fly the plane. Studies were performed by NASA in the 1980s in which they flew fighter planes into thunderstorms to see how the planes would react to lightning. The scientists quickly found that the planes actually encouraged lightning, because the planes caused increases in the electric field of the cloud, which in turn caused the lightning to hit the plane's metal body. Studies in the 1980s showed that airplanes actually attract lightning. While lightning storms can still be dangerous, passengers inside airplanes are safe from electric shock because they are actually inside a Faraday cage.
How is energy measured?
The SI unit for energy is the joule, J, but energy is often measured in other units. The calorie, cal, and the kilocalorie, kcal. Or food calorie are used both for chemical energy stored in foods and to measure heat. The British thermal unit, BTU, is most often used to measure heat in homes and industries. The kilowatt-hour, is used to measure electrical energy. A completely unofficial, but useful unit is the jelly donut. JD, the energy in a medium-sized jelly-filled donut. It helps relate all these units to a tasty treat. The table below illustrates conversions among the units. To use it read across. For example, 1J equals 0.239 calories, 1 calorie equals 4.186 J, 1 JD equals 239 kilocalories. In comparing fuels used to heat a home, natural gas, electricity, fuel oil, and wood, more has to be considered than just the cost of the fuel per mJ of energy. The furnaces that distribute the heated air or water have quite varied efficiencies themselves.
Do all relative velocities add?
Suppose you were riding on a spaceship moving at half the speed of light. If you were to point a laser in the direction the ship was moving, the person on the spaceship would be able to determine that the speed of the laser light was the speed of light, 300 million meters per second.
What is an electromagnetic wave?
Electromagnetic waves consist of two transverse waves, one an oscillating electric field, the other a corresponding magnetic field perpendicular to it. Light, infrared, ultraviolet, radio, and X-rays are all examples of electromagnetic waves. All electromagnetic waves travel at the speed of light when they are in a vacuum. Electromagnetic waves are characterized by their frequency or wavelength and amplitude. Electromagnetic waves differ from other waves in that they do not need a medium such as air, water, or steel through which to travel.
What is the standard model?
The description of all the particles described below is called the standard model. A model is something like a theory in that it is intended to explain observations. But it is not as complete as a theory. The standard model works very well, but there are still many questions about it. Some of these will be explained below.
What is static?
Not moving. All the forces and torques acting on a body must sum to zero. The net force on the body is zero, so the object does not move or rotate.
Can displacement be defined in more than one dimension?
More often than not, you have to define a displacement in 2 or 3 dimensions. As an example, suppose you want to locate a house that is 160 feet west of 1st Avenue and 200 feet north of Main Street. The displacement is a combination of 160 feet west and 200 feet north.
How is light emitted?
You undoubtedly have seen the light emitted by hot objects. Whether it is the dull red glow of the heating coil on an electric range or the orange glow of the element in an electric oven or the bright yellow-white of the glowing filament of an incandescent lamp, you have seen light emitted by hot objects. Even the yellow glow of a fire comes from light emitted by hot carbon particles. Energy, usually from stored chemical energy, is converted into thermal energy. That energy is transferred to the surroundings by radiation, including light. Unfortunately, producing light in this way is very inefficient because about 97% of the energy goes into infrared radiation that warms the environment rather than light that can be seen. Because of their large energy use, many countries will be banning incandescent lamps in the next few years. A close-up shot of a transparent LED. LEDs use the same materials as laser pointers and operate more efficiently than incandescent lights. Light can also be emitted by gases and solids. Neon signs are one example of a gas that glows because electrical energy is converted into light energy. High-intensity lamps use either sodium or mercury vapor to produce intense light. Fluorescent tubes and compact fluorescent lamps, CFLs, use electrical energy to excite mercury atoms. The ultraviolet emitted by these atoms causes compounds deposited on the inside surfaces of the lamps to glow. The colors can be chosen to emulate incandescent lamps or daylight. CFLs convert up to 15% of the electrical energy into light. Lasers, mostly used today in CD and DVD players and supermarket barcode scanners and pointers, usually consist of a small crystal composed of a mixture of elements like gallium, arsenic, and aluminium. The lasers produce single-color, intense light that is emitted as a compact ray. The LED lights that are often used as on/off indicators, traffic lights, car tail lights, stop, and turning lights also use electrical energy and the same kind of materials used in laser pointers to produce light that is radiated into many directions. White LEDs that are beginning to be used in home lighting are costly to produce, but are much more efficient and last much longer than incandescent lamps.
How did Luigi Galvani's experiments lead to the development of current electricity?
Galvani believed that the flow of charge from the nerve into the muscle caused the contractions. His fellow scientist at the University of Bologna, Alessandro Volta, 1745 to 1807, recognized that Galvani's frog leg was both a conductor and a detector of electricity. In 1791 he replaced the leg with paper soaked in salt water, a conductor, and used another means of detecting the electricity. He found that charges flowed only if the two metals touching the paper were different. The combination of two different metals separated by a conducting solution is called a galvanic cell after Galvani. Volta went further. He found that the two metals that produced the greatest electrical effect were zinc and silver. In 1800 he stacked alternating discs of zinc and silver, separated by a card wetted with salt water. He found that this device, called the voltaic pile, was a continuous source of charge flow. Sir Humphrey Davy showed that the charge flow was due to a chemical reaction between the metals and the conductive solution in the cards.
What is an amplitude?
The distance on a wave from the midpoint to the point of maximum displacement, crest or compression.
What is an electroscope?
A device used to measure electrical charge on an object.
What is an elastic potential energy?
The energy in the squeezed spring or stretched band.
What is the total internal reflection?
Occurs when a ray of light in a medium with a higher index of refraction strikes the interface between that medium and one with a lower index of refraction.
What is a lever?
A lever is a bar that rotates around a fulcrum or pivot. The locations where the input and output forces are exerted relative to the location of the pivot determines the class of the lever. As shown on page 76. The width of the arrows illustrates the force while the length shows the distance moved.
How are refrigerator magnets made?
Examine a refrigerator magnet. It is flexible, feels like rubber, and only one surface is attracted to metals. It doesn't stick to a stainless steel door unless the stainless has been coated with steel. It's made of rubber that has been impregnated with ferrite particles and magnetized. Small pieces, each a dipole, are then pressed together under heat to bond them into one thin sheet that can be cut, folded, and bonded to other sheets.
What is the buoyant force?
From the equation obtained in the answer to the last question, you can see that when you place an object in water, its weight is reduced by the weight of the water displaced. The reduction in weight, object, weighter. That is the net upward force of the water, is called the buoyant force.
What is a gas?
State of matter in which the atoms are about 10 times further apart than liquids or solids, and forces between them are very weak. A fluid that assumes the shape of its container.